Okay, we're going to continue for use raster objects in geoprocessing. So to use the spatial analysis geoprocessing tools, we need an ArcGIS spatial analysis license. So we're going to go to the ArcMap. And when working in the Python window, we can set this from within ArcMap. So we go to Customize and Extensions, and we're going to check everything. So I'm going to make sure that spatial analysis is checked. And then we're going to close the window. In working with raster datasets in Python scripting, it is common to work with raster objects. Most raster geoprocessing tools return raster objects, which can be saved as rasters when necessary. And now we're going to open the Python window. It's down here. And this allows you to see immediate results from running each line of code. And now we're going to type the code. And from ArcPy and import environment, then we will have workspace, and equals equal and my path from exercise 9, and then we have out raster equals arcpy.cell.slope, and we will have an elevation there. And because I think it's already exists, all right, let me call the last line. It should be slope there. All right. Why it's not working? All right, there. That's our slope. Now the new raster out raster is added to the ArcMap table of contents, and now we're going to determine the permanent status of the raster, and I will describe and equals arcpy.describe. Oh, please describe better. Oh, please. All right. Sorry, describe equals arcpy.describe, and then out raster. He enter. Oh, I need the parenthesis, and then we will print describe dot permanent. Alright, so now it says false. So the new raster is only temporary. And we can also determine the raster status by examining the layer properties in ArcMap. When we exit ArcMap without saving the map document, the temporary raster will be deleted. So the save method can be used to make the raster permanent. And I'll just say our raster, save, call it slope. All right, and then hit enter, and our raster is saved. And if we go to the folder, Python, and then okay, and now result, and right here. So now our slope is saved. All right, and then working with rasters, it is common to import all the functions of the ArcGIS module, and which we can do next. And this module shortens the code to call geoprocessing tools. So now we're going to run the tool, and when I finish this, I'm going to do it in ArcGIS Pro. That will be interesting, excited. All right, so import, and then our raster 2 equals aspect. And you notice that the tool's name is, the first letter is capitalized. And our raster 2. And then we get the aspect. And we will, our raster 2, we will save it. Save an aspect. There. And now it's saved. And we do have aspect right here. And we're going to use map algebra operators. So the ArcGIS module contains a number of map algebra operators, so which we will use next. And then these operators make it easier to write map algebra expressions in Python. And we're going to write the code. So elevation raster, elevation raster equals arcpy.raster, and then elevation, hit enter, and we go, and running this code creates a raster object by referencing a raster on disk, which using raster objects makes it easier to use raster datasets in code. And now we have out raster 3 equals rater, and then elevation raster, and we're going to times 3.2a1. Hit enter, and now we got an out raster 3. Our raster 3 dot save, and we called it elevation and underscore feet. There, and it's saved, and we have elevation feet here. So now running this code converts the elevation values from meters to feet and saves the raster object as a permanent raster. The map algebra operator star is used instead of the times tool to make the code shorter. So map algebra operators include arithmetic, bitewise, and Boolean, and relational operators. So now we will have slope equals slope. You have to capitalize slope. And then elevation raster. And we will say, alright, and then we will have good slope equals slope less than 20. And good. Alright, something wrong here. I didn't type slope. Alright, and then we have a good slope equals elevation and raster less than 2000. Good final equals good slope and good elevation. No, good. Okay, it's a slope, alright. And then good. Okay, now I think good final equals, alright, good ELV. Alright, I didn't type good ELV correct. Yeah. It's good ALV elevation equals elevation raster less than 2000. There. And good final equals good slope and good elevate. Alright. Good final dot save. We call it final. There. Alright, so that's our good final. That's how we get. So running this code creates a new raster indicating slope less than 20 degrees and elevation less than 2,000 meters. And the result of the code, it's right here in this figure that it illustrates how map algebra operators can be used to carry out a series of geoprocessing operations. So all the outputs are temporary raster objects and only the final result is saved. All right. And now we're going to work with classes to define raster 2 parameters. So many raster tools have parameters that have a varying number of arguments. The ArcGIS module has a number of classes to make it easier to work with these parameters. So we're going to work with a standalone script, and then the first task is to make sure a license for the spatial analysis extension is available, which is available. Alright, then we're going to back up to Python Wing, and we're going to make a new script, and I'm going to save it. File and save as, and we're going to call it slope. Oh, it's already exist. Click nope and then click cancel, and I'm going to open it. Alright, I think I have it. Alright, slope, click open, and we do have import ArcPy, and from ArcPy import environment, from ArcGIS, and then import environment workspace that I have the path name, and if ArcPy check extension spatial equals available, and column ArcPy checkout extension, we have a spatial out raster ArcPy sa and slope, capitalize S, slope and elevation % rise. And then we have out raster, save, slope per, and then we have ArcPy check in extension spatial, and else, print, and spatial analysis license is not available. And we're going to run it. Alright, something wrong is here, and I still have to figure it out. Alright, so that's why I'm going to check if slope final will work. If not, oh, that's not this one. Alright, then I will have to retype it and see what's wrong here. Okay, we do have an import ArcPy, and from ArcPy import environment, and then from ArcPy.sa import, and oopsies, import, and I do have a star mark in environment, and then we have a workspace, and workspace equals this. Alright, and then if ArcPy dot check extension equals spatial, and then equals available, and then ArcPy check out extension, we will have spatial, and then we have our raster equals ArcPy.sa, and then slope, we have input raster is elevation, and we have output measurement is percent underscore rise,